That was actually pretty good. I mean, for the first try, people in Germany, where I come from, get this wrong all the time. How do you pronounce that? No, sorry. So how do I pronounce it? Krutisch. But that's a very German way. Well, first of all, thanks for inviting me to this conference, to the organizers. It's really an honor to be here, and it's like the second time I give this talk. To change things up a little bit, I changed the aspect ratio, so it's not as boring for me. And yeah, I love to see. I love this place. I love to see you all here. So let's get started. I'm going to talk about building automations. And if you really think about it, most of us are probably doing this for their day job. You know, we are building systems that automate specific things about someone's job, or I don't know, ordering something online or whatever. So the question is, why do we do that? And my clicker doesn't work. So why automate? This sounds like a rhetorical question, but I think it kind of makes sense to just take a step back and think about why do we automate things at all. And I guess you know, most of us would probably answer, I don't want to do this over and over and over again. This is stupid. Sometimes repetitive work can be you know, meditative in ways, but most of the time it's just not, please make this stop. It sucks. And also it turns out that humans are not really good at repetitive stuff. You know, we tend to make mistakes. Yeah, I mean, I do these things, I do mistakes all of the time. For example, I forgot to take a button with me, which I wanted to show you. There's lots of very nice buttons here. And if you know how to make them, there's this machine where you have to pull a lever down, and then you have to turn something around, and then you have to put the next bits in, and then you have to turn it around again, pull the lever down again. And I do this myself just out of, I don't know, I like it. And I managed to do like 20 to 30 buttons in a row, and then I make a stupid mistake. And then I end up with a wrong, you know, with 2 buttons pressed into 1 or something. And yeah, that just happens. It's not in the human nature to do these things. And that's also how car crashes happen, right? We kind of drive on a road, you know, again and again, the same road every day, every morning. And we do this over and over again. And at like the 6,515th time we're actually driving this road, we're making a stupid mistake, and someone hopefully didn't die. So that's a very good reason to automate things, I guess. And also, you know, obviously, people automate things to make things cost less, because if you can automate something, it's probably too expensive to pay a human to do it. That's not always true, as we all know, but for most cases it probably is. And in contrast to that, machines, I hate to break it to you, but machines don't have feelings. Yet. They usually don't make mistakes unless they break. And if they break, you know, really bad things can happen, but we can kind of fix that with monitoring them and you know, keeping them in good shape, doing the maintenance. And then they do a pretty good job of doing the same thing over and over again. And also, if we're talking about IT, computers are pretty cheap. You know, if we want to automate something and we need to buy a new computer for it, well, that's not that much money. That's a different story, of course, with industrial machines. And sometimes it's not even cheaper to buy a machine than to make humans do it, but maybe the job sucks so much, or there's a hazard, like you're working with, I don't know, you're painting a car, for example. You don't want to do that by hand because it's a pretty bad job with really, really bad health risks. And also, error rates are usually higher if humans are doing it, for the reasons I told you earlier. So in general, if we build automations, we try to make our work more enjoyable. We try to make less errors. and hopefully it will also cost less, and or reduce the workload, which is great because most of us have most of the time have a lot to do and not much time left for the things we really want to do. Which brings me to the downside. So far I've only been talking about the upsides, right? The positive things. And I think in our industry we are pretty much still supply constrained, which means all of us have enough work on our plates. There's no such thing as a large number of unemployed programmers for some reason, at least not like taken globally. And that's of course not true for other industries. So we have seen industries that have been disrupted by automation technology, and people fall out of this system, and that's bad. But I don't want to talk about that because that would be a whole different talk, probably also for a different type of conference. So I'm going to talk about 3 examples. The first 2 will be about what we currently do with automations. It will be testing and deployment. And then I'm going to talk about something which we are trying to automate, but not many people are doing it, which is dependency updates. So let's start with testing. Whoa! This is really going crazy. So let's start with testing. Yeah, I mean, who in here does unit testing for their Rails apps or for their stuff? I want to see nearly all hands. Okay, so you probably do something like this, and it takes a while. So why do we do automated testing? That's an interesting question. Well, I mean, think about it. You would want to kind of replicate what's happening here manually. It would be pretty boring. It would be pretty repetitive. And it would also be pretty error prone. You just forget to test one thing and you deploy to production and everything breaks, and that's not good. So unit tests are pretty cool because essentially you can do all the things that unit tests do. You can do manually on a command line or something, but usually manual tests wouldn't work that way. Normally if you do a web application, you would just load up the web application and click around and see if everything works. And unit tests simply work on a different abstraction level, and so you're able to basically test 100% of your application, and it's also really, really fast. If you would do all of that by hand, that would be kind of tricky. And like I said, code coverage is great if you're doing it right, and we have tools to check that. So if you would only, for example, you're working on a change in an application and you would only test like the one API you're currently working on, and something else would break because of your changes, you wouldn't notice if you would only test that. And since you have a test suite that runs all your tests, you can catch that pretty easily. And that's a pretty complicated task if you want to do it manually. And so good automations, that's my first lesson, make the easy trivial and the complicated possible. Just another thing about unit testing, who in here uses something like autotest to trigger tests automatically? Like running in the background, and every time you save a file, your tests run. So it's kind of interesting to see that not many people are actually doing it. And I personally ran into a lot of problems doing that with, sometimes tests won't be triggered. And actually, I've learned unit testing from some people who've been doing it for ages, basically, inventing some of the unit test frameworks in Java and other things. And they've been telling me that they think that actually triggering the tests and waiting for the test to complete is part of the red-green refactor cycle thing. It needs to be manually, which I find very interesting. It's a conscious decision to not automate something, and that's lesson number 2, which is sort of a no-brainer. Not everything that can be automated should be automated. So, going on, what would you automate next if you're talking about tests? Continuous integration. So you have your test suite, and now you have an external box that every time you commit a change to your version repository, to your Git repository. Continuous integration would kick in and run your tests for you. That's how we do it in Ruby land. You know, continuous integration used to have a lot of other things to do in larger projects, but for Ruby projects it's mostly running tests. And the interesting part is that for a long time this used to be a very complex thing. You would have to set up a CI server, and then you would have to install, I don't know, cruise control, or later on Jenkins, stuff like that. And nowadays we can just go to Travis CI, configure the repo, and hit go, and that makes it so much easier. So the question is, if I run my tests locally, why would I run it again on a server? And you know, the first reason is if you're running it on a server, and that's not so true for Travis, of course, but if you would set up your own server, that can be true. It's closer to production, especially if you're using a Mac and your application is running on a Linux server somewhere. You can actually check that all your stuff that you're using is actually also working on Linux, and that's pretty cool. And even if you're using Travis, you can choose between different environments and make sure that it actually runs in them, so that's pretty nice. The other thing is that you can force your CI to actually use a clean install, and that's pretty important because you catch everything. I mean, who am I telling this? But you catch everything that where you forgot to check in a code change, or a configuration change, or you forgot to add a dependency or something, and CI will just catch that for you because you're running a clean install, and also do all your migrations run perfectly and stuff like that. The next one is the typical things, like how many of you have checked in code before running their tests? Once or twice, right? I'm pretty sure there's actually more than that, but it's okay. So that's something that just happens, and CI catches that. You know, you check in something, you've been in a hurry, it happens to the best. Damn it, but CI has your back. And that brings me to another aspect which is pretty important, which is part of the name, which is integration. Continuous integration means that you're taking the changes from all your developers on your team and you're testing them together for the first time. And if you're running a rather modern approach to managing projects, especially with GitHub and GitLab and whatnot, your flow probably looks like this. So you have lots of developers working together on a team, and instead of just pushing to master, what could happen, right? You're opening up a pull request, and the pull request gets tested, and only if that is green and your other checks, like your code climate checks and what have not, and a code review by one of your team members is green, only then it gets integrated into master. And that makes development much more stable, I would say, for the most part. And the lesson here is that good automations integrate into your team workflows. So, does this look familiar to anyone? Certainly does to me. It's not a real screenshot. I don't have that many tests, haha. So the thing with test suits is that for some reason they tend to grow bigger and bigger and longer. And we will have a talk later on by Vlad, who will be talking a lot about how to optimize those. So if you want to know how to get a long-running test suite faster, please don't ask me, because I have no idea. Apart from use fixtures, which a lot of people don't like to hear. So what I want to talk about here is that if you have a long-running test suite and you have a running CI, one of the things that you can do, if you, for example, if you have lots of high-level tests, you know, a cucumber suite or something like that, or other integration tests, system tests, and you're using a lot of JavaScript stuff, for example, that just takes a long time. And what you can do is split up your test suite so that you don't have to run everything before you actually commit. It's kind of dangerous, but there are ways where how you can actually make sure that stuff is working. And the cool thing about CI is that it's actually asynchronous, right? It's running in the background, and you can just push your code, and after that you can continue with the next thing. You're not supposed to wait for your tests. And I've had discussions like yesterday with people where, and I know a lot of you probably have the same problem, test suits running for like 25 to 30 minutes, and that's bad, and you should change that. But on the other hand, I mean, think about that. If you're doing like 5 to 6 commits a day, you're already wasting like 3 hours a day just waiting for the test suite. That doesn't make any sense. And so the lesson here is asynchronous automations are just a really great way of, basically unblocking your developer workflow. So the next thing I want to talk about is deployment. And that's something that, you know, I at least remember. I'm a web developer of the old block, and I remember how things were back in the days. And nowadays, my deployment workflow looks like this most of the time. And it's taking some time, but actually what it does in the background, if you think about it, what Capistrano does and what it automates, that's pretty amazing. And I can remember starting up my FTP client, pushing some files over to a web server, and then because it was a web app, you know, with a database in the background, I would open up the MySQL client and, you know, start adapting the tables to what I need for this update. And that's pretty damn cumbersome. And now we have Capistrano, and before that, if you think about what Capistrano is doing, all of the tasks, if you would have to do that by hand, it would be pretty boring, repetitive, and error-prone. Think about forgetting the database migrations. Oh my God, what can happen? And also, speed is important when deploying stuff, because depending on how you set up your deployment, there's always this weird moment where database migrations are already run and the code is still the old one, and you want to have that as quickly as possible. And of course, things totally get out of hand if you're running multiple servers, of course. And the cool thing here is that Capistrano also, not invented, but kind of took over best practices for doing deployments in a way that I didn't think about beforehand. It was something like checking out the code into a new directory, and then only if everything happened to make the update work, you're setting a new symlink to that directory, and so the new code gets used. And that essentially turns deployment into an atomic operation. You can roll it back, or you can stop somewhere in the middle and nothing would have happened. And you can do a rollback if you need to. And that's basically best practices that existed before that turn into an automation. And so good automations always codify best practices. Now, the latest craze, not very latest, I mean it's been around for a few years, is stuff like continuous delivery. If you have tests running automatically on your CI, you can also say, okay, this test obviously, this piece of software obviously works, so let's put it on a staging server, for example, so that people like product and QA can take a look at it and see if everything works fine. And that's pretty cool. It's a very low risk operation. Tests run, green, go, put it onto a server. If you want to do the next best thing, which is continuous deployment, which means you actually put it into production. You can, if you really think about what's happening there and what could go wrong, you will agree that it is a much higher risk operation, right? And if you look at how big companies, one of the best documented examples is Etsy, for example, what the Etsy people are doing. If you look at what hoops they actually have to jump to make that work. So you deploy only to a certain subset of your servers, and then you monitor those servers. Do they have an elevated error rate, or do they have suddenly a high CPU usage, stuff like that? Do they suddenly have very long running queries? And if anything goes wrong, you just roll back. And if everything looks fine for a few minutes, then you start updating the rest of the server. So you have a staggered rollout. And so the lesson here is that you have more complexity if you want to automate higher risk automations, basically. So the next thing I want to talk about is dependency updates. And for that, I just need to set the stage a little bit. So how many of you run something like bundle outdated regularly? Like, I don't know, something like every 2 weeks or every week or something? That's not a lot of people, actually. So how many of you know Gemsurance and use it on a regular basis? One hand in the back. How many of you know Bundle Audit and use it on a regular basis? A few more people, great. So we've been talking to a lot of people, a lot of teams, and most of them say, well, it's not that much of a problem. And we kind of think that this is problematic. And let me just make a short excursion into why I think this is problematic, and then we'll be getting back to automation itself. So the main reason to do updates on a more regular basis, to me, is stability. Because you can say, okay, I don't need the new features of a library or something, but your software actually doesn't live in a vacuum. It's not, if you deploy it to a server, people are using it from the outside, and it interacts with the world in various different ways. And so it actually does get stale if you don't update it regularly. And the main thing here is, of course, security. Like, there's a security, I don't know, a new security hole in Rails, for example. It happens. I mean, I get regular emails from Aaron that tell me that something is broken again and I need to update my Rails. And the thing is that if you don't update your dependencies on a regular basis, what happens is that the cost for actually doing an upgrade, because you have to, because there's a security hole somewhere, is actually going up more or less exponential. These are not real numbers. I made them up, I have to say, because otherwise I get rightly yelled at. But this is what I feel. So I've been doing this a few times, and it really sucks. And the reason for that is that you have cross dependencies, so you cannot update a certain gem in isolation. You have to update another thing as well, and then you end up with this long process that gets longer and longer the less frequent you do your updates. And that's one of the main laws of maintenance, that the pain of doing regular updates is best in small doses and taken more regularly. So how does a best practice process for updating your dependencies would look like? That's something that we thought about a lot. And I think one of the most important things is you do it one at a time. Don't do bundle update. That's the most stupid thing you can do, because if something goes wrong, you don't know what caused the problem. And so you do bundle update this and that, bundle update this and that, and see if something goes wrong. And if something goes wrong with that one update, you know exactly what caused it, and it's much easier to find the problem. The next thing is finding information about the update. And I'm coming back to that later on, but that's really important. You have to look up the changelog, or you have to find out what's changed by looking at the commits to make sure there's no breaking change that you need to work against. In theory, we have something like semantic versioning that would help with that. Yeah, let me leave it at that. And the next thing, of course, is you have to make sure that your tests are running. Maybe you have to do some work to do that work, get that working, but that's how it goes. Rinse and repeat, right? Do it for the next gem, and for the next gem, and for the next gem. So we thought about how to make it better. The first thing that we do is a little change in mechanics. So usually if you're doing a software update, you kind of look up, okay, what has changed? What has been updated in the meantime? And what we do is we just listen to what RubyGems tells us and say, okay, we pull in the changes, and every time a gem gets updated, we kind of look up, do our clients somewhere use this dependency, and if yes, we just do an update. So it's more like a push thing. And we do it one at a time. So an update for rake comes in. We do essentially the equivalent of a bundle update rake, and we do it on a new branch, push it to your GitHub repository. It gets tested by CI, which is great because you don't have to do that by hand. That's still all automated away. And then we try to find as much information as possible. We start with the commits because that's usually easy if we know where the gem has its source code. And people use tags, which is luckily somewhat popular nowadays. We look for a changelog, and if people use GitHub releases, that's great as well. And let me quickly say something about changelogs, because I think I do a lot of Ruby development, but I also do a lot of JavaScript development, and for some reason the JavaScript community is better about that. The Ruby community is a little bit slow on the uptake in terms of do they write changelogs. And I don't want to criticize open source authors for that too much, because I know that open source is hard work and they are very easy to burn out on this, and it's a very thankless job most of the time. So I'm not stressing this too much. So if you want to help with this, this is a pretty good way of getting into open source development as well, you know, documentation and something like writing changelogs. All right. So yeah, please write changelogs, or please help people to write changelogs. I think they're very important, because if you don't have them, you actually have to look at commits. That's kind of crazy, I think. So when the tests are run and we know, okay, this update kind of works, then we just create a pull request. And the pull request continues the code change, of course, which is usually just gemfile lock something. And we tell you what has changed, and we try to, you know, bring all the information in there. And everything, and if everything is fine and you know enough about the update to actually make the decision, you just have to press the merge button and you're done with your update. So that's how we try to integrate best practice into your workflow to keep your software up to date. And it's kind of also interesting to look at all the things that we're not doing. Who in here gets that joke? Okay, not that many people. Please do me a favor and try to find the original DHH Rails video. It's a fun thing to watch in 2017. So, for example, we're not sending any additional notifications. You don't get an email from us, hey, this has been updated, because nobody wants another inbox, right? We don't want to have another place where we have to look up if things, if we need to do things. And also, you know, we think that pull requests are actually conversations about code. You know, that's where or code changes, so to speak. So it is the natural place to have your updates as well, because it's a code change. And because I don't have time, I'm going to skip this one, which is convenient because it doesn't mean anything to you. And so afterwards, we also try to clean up behind ourselves. So we are, if you merge the pull request, we can delete the branches. If we don't do a pull request for some reason, we can delete the branches as well. And if you haven't updated a software and a new version of that, haven't updated a gem and a new version of that comes out, we can close the old one, the old pull request, and make it point to the new one. And that's all just to keep noise down, basically. And we also try really, really hard to not, you know, send you pull requests where you can do nothing, like something where actually installing or updating the dependency didn't work because bundler failed for some reason. We don't even notify you about that. And that's the number 7. Good automations just stay out of the way. And I'm closing with, I hope I have enough time for this. reasons, it's a slightly contradictory note, like reasons why not to automate. And I've been in a few places where people were actually afraid of their job and like actively resisting automating stuff. I've seen that. It's rare in our industry, but I've seen that. But most of the, a more common thing is this one, like nobody has time to do automations in a team because everyone is so busy churning out features for your clients. And so you never get to that point where you actually write that automation. And that obviously is hurtful because then you're doing all these repetitive things over and over again because you don't have time to automate them. That's kind of bad. So the next reason is a bit more substantial, and that's loss of control. Every time you automate something, you have to give away a little bit of control. And this can be just a thing of a feeling, a gut feeling that you have, but it can also be something pretty substantial. And I talked about the Etsy thing, all of these crazy things that you have to do to actually make automatic deployment work. But Etsy can do that because they have hundreds of developers deploying hundreds of code changes up to hundreds of servers every day, right? And so at scale, that is not a problem because you can have a team in-house that only does this one thing. They only make sure that the automations work. And so that totally makes sense. But if you're like a handful of developers and you deploy to 2 to 3 servers, does that make sense to do continuous deployment? Maybe not. So it's a question of cost versus benefit, and talk about automation wouldn't be complete without an XKCD comic. So that's how automations also can go. And in the end, it's also a question of risk versus benefit, because coming back to that continuous deployment scenario, continuous delivery to your staging server is a much lower risk operation. And so does it make sense to do that for like your handful of team members? Probably. It's very easy to set up. You don't need a huge monitoring thing around it. And so that brings us to lesson number 6.1, which is automating high-risk tasks almost always are only worth it on large-scale systems. And that's why we don't automate actually updating the dependencies in your repository, because you need a lot of intrinsic systems knowledge to know that you can make that update. We cannot do that. The only alternative to that would be to do observation and see, okay, is your software actually working? And so my last things are, there's this notion that we need to automate everything. And that sounds like a worthwhile goal, but there is a thing called premature automation. And since I'm really running out of time, I think, just quickly, I have this t-shirt on me. You probably have seen flyers lying around. We are actually building this as a product. It's available at depfoo.io, and if you're interested in getting your updates automated, please talk to me or grab one of those flyers. I have buttons as well, and we do open source updates for free, so if you have an open source project you want to run this on, please try it out. And this is my last slide. John Osborne, who's the CTO of Etsy, wrote a lot of great stuff about automation. There's Courtney Nash's Automation Myths, which is a really great post. And yeah, a few links. I'm going to push this online, of course, later on. And with that, thank you very much.
Yeah, we actually have a couple of minutes for questions. Any questions right there?
Hello, thank you for your speech. And I'd like to ask you, I've seen a slide that you told us that going to CI, just doing a continuous integration, means that we're losing some control. So why do we lose control? The only control that people do is just code review, and we're just lifting all the routine from us, giving it some RubyConfBY, linter, whatever else, and we can just check the architecture and all the routine, the linters on this continuous integration will do for us. So why it is losing control. I think it's more gaining control, that we can focus on most important things and the less important routine things Linter will do for us.
Yeah, I mean, the loss of control thing is thought more general, so it's not exactly about CI. But but it's, I think most of the time that loss of control is more felt. Like it's I'm automating something, and I'm not. I mean, the thing with CI is that I think you're totally right. It gives more control to the overall team, but I've seen teams where people were not very keen about having a machine controlling their work, and that's just perception, and it's wrong, and we all know that, but it's not really. You're right, but sometimes automations give, like continuous deployment, for example, gives away a little bit of control if you're not doing it right.
Of course it is, but okay.
Yeah.
Thank you for speech.
Thank you.
More questions? 3, 2, right there. When I start counting, we always like question.
Yeah.
I should use it every time.
Hello, thank you for the speech. Could you tell us about how are you doing continuous delivery with scripts, or this is some kind of app?
Continuous delivery.
Yes.
Currently, I'm not doing it actually. So what in my previous job, I actually did that with a very simple. It was basically calling a Capistrano script from within the CI. And I think a lot of people are doing similar things. There are some systems that automate that away as well as a service, but it's a very simple setup.
There is a Strano project on GitHub, which is supposed to deliver Capistrano 2 deployments, but it's not supported for Capistrano 3 anymore.
Yeah. Yeah, so we managed to get Capistrano 3 working from within GitLab CI or something. It was,
okay, thank you.
Yeah. There's another one?
Yeah, we have last question. Okay, we have two questions. Last two.
Yeah, thanks for the speech. My question is, have you ever used Docker to pack your applications?
No, I haven't.
So that's all.
Okay. Was that a pitch for Docker?
Easy one.
Yeah, I have another one, a small question related to your product. I'm interested, is it possible to provide like environment in which those dependencies are tested? Like, for example, in our current project, we have like different production systems, like from Debian-based to CentOS to some old-fashioned CentOS, some Docker stuff and whatever. So is it a way to provide like something to build environment dynamically to test dependency? Because in some systems they know, like in some system, okay, like bundle update might succeed, but in others it's not.
Yeah, totally. So what we are doing, we are not running CI stuff for you. So you're setting that up with Travis or whatever. So what we are currently relying on is the status API of GitHub. So if you're using Jenkins, for example, to run your builds, and Jenkins pushes back the status, our service will work. We are really just doing the dependency updates and then relying on your CI to test that. So something like that would totally be possible. The only kind of twist here is that we're currently really just doing MRI, and so that's kind of a bummer, and we want to change that. But if you, for example, test JRuby or something, you also have a problem where we can't really update the gem file lock because it will be invalid for that platform, for example. And so it's kind of tricky, but we are going to expand that. It's a very, I have to say, it's a very young project. But if you want to ask me about our product, I guess it would be better to do that afterwards. We're out of questions?
We're out of time for questions, actually. So thank you, everyone, for questions. Let's applause.
Thank you.